Hello, everyone. Thank you so much for joining us this evening to discuss the scientific advancements that were brought about due to the 9/11 attacks. We're happy you could be with us tonight. Before we begin, I'd like to remind you to post any questions you have in the chat, and we'll try to get to those at the end of the session. And please also know that there is going to be a link for credit for attendance posted at the end, and that will also be in the chat. So be paying attention to that towards the end. To get us started tonight, I want to welcome our two speakers, Professors Natalie Russell and Amna Qureshi. Thanks for being here with us, guys.
Thank you, Misty. Welcome, everyone. I look forward to talking with you about this tonight and appreciate this whole series that the Social Sciences Department has put together to help us remember 9/11. And Amna, would you like to welcome now or when you start your part of the presentation?
I'll do it when I start.
Okay. All right. So, Misty, if you want to...
hold on one second, Natalie. I'm going to read y'all's bios real fast.
Oh, yes. I'm sorry.
I just wanted to say hi to you.
Okay. Hello.
So Natalie Russell is originally from New Mexico and is a graduate of New Mexico State University, where she earned a Bachelor of Science in Biochemistry and a Master of Science in Molecular Biology. She's previously worked for the Southwestern Institute of Forensic Science as a forensic biologist and trained at the FBI Academy in DNA analysis. I'm sorry, I had to skip a word because I don't know how to say it. She and her husband, Aaron, have two teenage sons who are dual credit students at TCC. Natalie has enjoyed teaching biology at TCC as an adjunct and also as a full-time faculty member. Amna Qureshi completed her Bachelor of Science in Biology from the University of North Florida and her master's degree from Georgia State University. She has taught and volunteered as a science teacher during college, and she moved to Texas with her husband in 2013. She joined TCC in 2018 and is currently a temporary full-time biology faculty member. When not grading papers, she likes to spend time with her husband and two sons. So again, thank you both for being here. We really appreciate it, and I'm really excited to hear this presentation.
Awesome. Thank you, Misty. So what we want to share with you tonight, obviously 9/11 was a tragedy, and through the tragedy, though, there have been some incredible scientific discoveries, advancements that we now have in place. So we just want to spend a little time. We'll talk a little bit about advancements in forensic science because of all of the identifications that had to be made. We'll talk a little bit about drone technology, and then we'll end with some really cool biometrics that Amna's going to share with us. So what I wanted to, if you imagine yourself the medical director of the state of New York when this happened, and now it's up to you to identify all of the people who, if we think about the Twin Towers, there were about a little over 2,700 people who perished in that attack. And that was a very overwhelming situation because in forensic science, typically up until that point, you have a few samples for every particular case that comes in and a few comparisons to make. So this was a completely different way of having to identify. And if you think about the samples that were coming, these are from, ground zero where there had been heat and there had been chemicals and there was a mixture. So the sample condition was not ideal, to say the least. The sheer number of samples that were collected, because obviously you have rescue workers and firefighters, anything they see that looks like it might have been, part of human remains, those are going to be collected because we obviously want to identify as many people for families as can be identified. So there were over 14,000 samples collected. And then if you add to that, then you have to have something to compare those to. So, reference samples can be anything from someone's toothbrush, something that would have had their DNA on it, but many times those were not available. So then you have to look at doing something like paternity or reverse paternity. So looking at family members, which means you have even more reference samples to compare to. And when you start thinking about that many samples and reference samples, that's a huge amount of data to do comparisons. And up until that point in forensic science, there was a way to compare samples. The FBI keeps a database called CODIS, where if you're working a case and you have a There's specific guidelines for what you can compare in CODIS, but there was a way to compare that, but it was not anywhere on the scale of what this looked like. Now, I will say to date, 40% of those who perished in the Twin Towers still have not been identified. So the effort is ongoing. And actually, Amna just sent me an article today that she read from earlier this week that 2 additional victims were identified just recently. So it is still an ongoing effort. But what did they have to do? Well, the first thing was they had to improve the way that they can get DNA out of samples. So these were samples that had been burned, that had chemicals on them. They were mixed with lots of other, dirt and concrete residue. So there had to be improved procedures. And then they had to validate new ways of sequencing when you don't have a full, complete profile. They had to get very inventive in the way that they were comparing these DNA sequences. And finally, of course, anytime you're dealing with big data, there had to be software to help them make these comparisons. And what you see there on the right, I'm sorry, that was a DNA profile, something that you would expect to see. So those little peaks that you see there in different colors, that is what we call an STR profile, or a short tandem repeat profile. This is what is used to compare, an unknown sample to a reference sample. So sorry, Misty, go ahead. So what did we get out of that? Well, in forensic science today, we have a better understanding and better ways for dealing with degraded DNA samples. So it's not just through natural disasters that we have degraded DNA samples. Many times in crime scenes, right, we will have degraded samples on clothing or on weapons. There are also many times we have what we call complex DNA mixture analysis, which means it's not so easy that, like sometimes on the crime shows where you take a swab of something and it comes out with this full and exact profile. Many times there might be 3 or 4 people that handled that, or in a crime scene, 2 or 3 people that bled on something. So it helped us better understand statistically how we can deal with DNA mixtures. One thing that I want to mention, so I actually was working at the Dallas County Crime Lab, or SWIFT, the Southwestern Institute of Forensic Science, when 9/11 happened. I still remember that I was actually driving down the North Dallas toll road on my way to work when I first heard it on the radio. And at that time, just to give you an idea of how far forensic science has come, around that time, I remember that we had a case where a perpetrator, a suspect, had actually broken in and burglarized a place. They had worn latex gloves so that they wouldn't leave their fingerprints, right? But they left the gloves at the crime scene. So we were super excited that at that point in time, we could swab the inside of those gloves and actually come out with a DNA profile for who wore those gloves. So that was a big deal then. So today, right, they are able to get DNA from much smaller amounts and much more difficult situations. So we would consider that trace DNA at the time because it was just someone who wore the glove. Trace DNA extraction now looks much different today based on the things they've discovered through all of this DNA analysis. Now let me switch gears a little bit and talk about drone technology. You probably all at some point have seen individuals flying these drones for different purposes. It turns out that the idea of unmanned aircraft or something similar to a drone goes back a long way. And so I have a little history there for you of some of the sort of key points in drone technology. One thing, though, that I want you to see is in 2002, the U.S. began to spend significant money on drone technology, so $550 million. By 2011, the budget had increased to $5 billion with a B for drones. And in 2012, all of our combined drone aircraft actually comprised 33% of the total aircraft for our military. So it's been a significant advancement in research on drones. And as you probably are aware, the military and the CIA use drones for multiple purposes. Surveillance is a very big one. Maritime and border patrol areas, as you know, they do use these for targeted killings. one of the most fascinating things to me is what's pictured here, which is what we call a nano drone. So military personnel can individually have one of these drones. Each person can have this. They have infrared and other kinds of detection on them. And it's a great way for them to surveil a couple of kilometers in area that might otherwise be dangerous for them to enter in before they send the drone out. So this is just a little background on drones. And then let's move forward and look at some of the sort of interesting and fun ways that drones now have a role in our society and our economy, really. So these are some of the things that Amna and I are going to touch on. So search and rescue, you may have seen some stories about how drones were used in this way. You may or may not be familiar with that they're used in agriculture, aerial photography, disaster management, and GIS or geographical mapping of inaccessible locations. And finally, similar to the military, the law enforcement uses these also for surveillance. So we'll go into some specifics about each of these. So let's start with search and rescue. So this is a picture from a drone that's using an infrared camera so that you can actually see, instead of using light to see what's going on, it's detecting heat, right? So that you can easily see in the dark where people might be located. This has been used multiple times to help locate missing people. One of the stories that's interesting, and you can read more about it if you like, is a couple of years ago, there was a 10-year-old boy that was missing in Minnesota, and they had, search parties, and they even had a helicopter. They had lots of effort to locate him, but it was actually a drone that was equipped with this kind of a thermal camera that ended up locating the boy. Now, fire departments are starting to use these for many reasons, but one is with these thermal images and special types of cameras, from way above the fire, they're kind of able to see about the fire science, where the major heat is, and it helps them to better attack where they can best fight the fire. Of course, police, one way they can use these if they have escapees or criminals that are at large and they run out in a field or they're somewhere where it's harder for them to locate them, they use these. Interestingly enough, they also use drones now to collect evidence in some cases. And so where I live out kind of in a rural area in Joshua. And in our neighborhood, I actually have a neighbor down the street who is a individual licensed drone operator. And he works with, many of the local police departments. And my husband and I like to walk the neighborhood, and you can almost guarantee when we go by his street, he's got his drone out. He has these huge, massive, expensive drones, and he's performing some kind of practice. So, for example, one time we went by and he had a huge chainsaw that was, he was taking from his drone from one location to the other. And it was like, what are you doing? He said, well, first of all, I'm testing the weight limit of my drone. But secondly, many times in flooding or other kind of situations like that, you might have to actually take a chainsaw or some other kind of piece of equipment to help people get out of their situation. So lots of exciting ways that drones are used to help people in search and rescue. Now, agriculture, this is so interesting to me, and it's called precision because it is very precise. It's very high tech. And these drones are used several ways. One is simply, instead of having, you've seen airplanes that crop dust. So it's more exact, and they can spray fertilizers in specific areas where it's needed, pesticide application to control so you don't have too much. They can also now, believe it or not, plant pods or seeds. And obviously the drones are very exact because of their GIS mapping on, how close together to put the seeds or the pods. The other thing that's interesting about these drones, because of the thermal camera imaging they have, some farmers are actually using these to scope out the health of their plants and also to tell what nutrition is lacking. And the other benefit to this is they can decide where in what areas plants need water, so it doesn't waste water. You're only watering those that need it, and you're sort of minimizing a fungus or something else like that that might be detrimental to the plant. And we get less runoff into our waterways of fertilizer and pesticides. And now I'm going to turn it over to Amna.
Thank you, Natalie. Hi, everyone. My name is Amna Qureshi, and I would also like to welcome you all to this presentation, and I would also like to thank Misty for organizing it. So I will continue talking about some more uses of drone technology, and this is one that anyone who watches YouTube is probably familiar with, aerial photography. So aerial photography is not just used by YouTubers these days. Filmmakers can use it for making documentaries, and it is a much safer option than what they had before. So previously, if let's say they're making a documentary on the Niagara Falls, or let's say they're doing wildlife documentary where they have to film wildlife and dangerous animals, they used to need helicopters before. Now they can just use drones and fly them as low as they wish, and get really good footage without the danger of either being attacked by an animal, or not getting an image because there's a helicopter hovering above, or in the case of Niagara Falls or other natural places that can be dangerous to film at. So drones can be used for aerial photography, and then for other fun stuff like wedding photography as well. And there's several different kinds of drones, and Natalie talked about the nano drone. They can be controlled, so the different types of drones can be controlled in different ways. Now they can even be used or controlled by our smartphones. So we've come a long way with all technologies, including drone technologies, to where it's not just military or farmers who can use it. It's just anyone with a smartphone and a desire to use a drone. Disaster management. So what you're looking at right now on the top, this is footage from an earthquake that occurred in Australia, and you can see that white drone hovering above it. And then the bottom picture is also from an earthquake, and this one happened in Nepal. And the bottom picture is actually footage from that drone. So when natural disasters strike, not just earthquakes like you see in the picture, but hurricanes, flooding, anything else, tornadoes, etc., that happen, it leads to a lot of destruction, disaster. People are stranded, homes are flooded, they cannot be reached by people, by secure or rescue personnel. And so using drones, we can survey the damage, we can survey where people are stranded, and we can rescue them. So in 2005, when Hurricane Katrina occurred, they actually used drones to survey the damage and to see where people were and where help was needed in a much safe manner. So prior to drone technology, you couldn't really have that. So that is one other advantage or use of using drone technology. And when I was looking this up, I actually came across a really interesting story of a man. His name is Pedro, and his grandmother was stuck in a hurricane. So a hurricane occurred. I can't remember which one it was. Unfortunately, we've had so many in recent years, but she was stuck. Her whole area was flooded, and she was stuck somewhere. They couldn't reach her, and he came up with this idea of having these like posters, a small, like 8 by 11 paper posters, which you can give to people before a natural disaster strikes, and then they can hang them or display them wherever they possibly can, maybe on a car, maybe on the rooftop or balcony, wherever. And the drone will come and it'll scan for those posters, and anytime it scans that poster, it tells the drone and the drone operator that there's a person here who needs help. So his story did have a happy ending. They did find his grandmother, but from that, from that disaster and tragedy, he came up with this idea of having that, poster available for people who are about to experience a natural disaster, and they can't vacate their home for whatever reason, and then the drone can scan it and let the rescuers know, all right, we have a person here, they're flooded, or there's an electrical pole down, or whatever the situation might be. Another, so kind of segueing into this particular slide, when you have a natural disaster and you have all lines of communication that are down, etc., etc., you need drones to survey that area to see the damage, to assess the damage, to see where people are, where the victims are, etc., etc. Taking one step further, drones can also drop supplies, and in the case of fires, they can drop fire retardant. So I'll read the statistic that you're seeing on your screen. In 2013, firefighters sustained 34 deaths and 29,760 injuries while combating volatile fires. So when you're fighting a fire, it's not just the fire itself that can kill you, it's also the smoke and the smoke inhalation. And unfortunately, again, recent years, we've seen so many fires. Currently, we've had fires in California burning for days. And when you have those fires, what they used to do, and what they still do, is that the helicopters will hover down to assess the damage and then also to spray fire retardant. Now, there's only a small height that they can reach. They cannot go lower than that because the smoke can kill the pilot or whoever else is in the helicopter. And so with drones, you don't have that issue because they're unmanned. So the drone can go much lower than a helicopter, assess fire damage, and then also drop fire retardants that you couldn't do prior. So here, what you're looking at is pranks. So not just, useful stuff for pranks, but fun stuff as well. This person purchased a drone and decided that he was going to throw a Grim Reaper costume and scare joggers. And this is just one image or video that I inserted. There are so many other ways that people have actually used drones to prank people. So biometric authentication simply means that they're using some physical feature on a person's body as a way to identify them. And the most common biometric authentication that we are aware of are fingerprints. And I'm not going to actually go into fingerprints because fingerprinting has been around for a really long time. After the events of 9/11 happened, there was a great demand to come up with different ways of authentication that were efficient, that were fast, that could be easily used so that people could catch either criminals or terrorists or people on the no-fly zone or the no-fly list. And so face recognition technology or facial recognition technology, retina scan, iris recognition, voice recognition, and then signature keyboard dynamics, they all, there was a great demand for all of these technologies to be developed. And they've come a long way since 9/11. They've come a long way. I mean, we have face recognition technology in our iPhones now, and that's pretty recent. And I'm going to go into each of these in the upcoming slides. So facial recognition technology was limited to characteristics related to the eye, ears, nose, mouth, jawline, and cheek structure. So pretty rudimentary. However, after 9/11, they've come up with much better ways, much detailed ways to analyze somebody's face such that it is now 99% accurate. So I'll just quickly read the second part. It says now it does this by comparing structures, shape, and proportions of the face, distance between the eyes, nose, mouth, jaw, upper outlines of the eye socket, sides of the mouth, etc., etc. So it's incredibly detailed such that the chance of error is reduced to just 1%. And facial recognition technology can be used in a big crowd. So let's say there's a criminal on the loose, and let's say they're walking in a crowd. Hypothetical situation. However, using facial recognition technology, if there is a CCTV camera, if there's a security camera monitoring that crowd, and it is equipped with facial recognition software, then that person can be caught, right? The camera will basically pick up that, that's the person of interest. Now, of course, that person's face has to be in the database. My face is in not any database. So if I'm in a crowd, even if my face is scanned, it's not going to give any results. So you have to have a database with that person's facial image already for you to catch them. So what are the uses of facial recognition technology? Picking a suspect out of a crowd, like I said. So, let's talk about 9/11. If we had facial recognition technology back then, and if it was being used, and if they had the database of those people who did those acts, they could have been picked out in the airport crowd. Unlocking phones. iPhones. My husband has an iPhone and he wears glasses, but with or without glasses, the iPhone can easily recognize that it's him and unlock his phone. Logging into bank accounts, paying at store. So I'm not sure if or how widely used it is in America, but some other countries like China, they will have this option where when you go to a store, you can just scan your face and it'll pay like that. And then surveillance through security and other cameras, I touched upon this earlier. And then this is an interesting one. In China, it's even used to catch people stealing toilet paper from public bathrooms. So they had this issue where people were stealing toilet paper. And apparently they have these facial recognition cameras in the bathrooms, hopefully just facing the sink, not the toilets. But they were trying to catch people like that. And I also read that in Israel, there was a school where they felt like the teachers were taking really long breaks, lunch breaks, and so they had this facial recognition cameras installed there as well to catch the teachers. So I wouldn't take a long lunch break, and if that would affect my students, but I hope DCC doesn't have this technology to catch us. Iris recognition. So what you're looking at right now, on the right-hand side, first I want to point out what the iris is. So on the rightmost image where you see that black hole, that's the pupil of the eye through which light enters. Surrounding it, that beautiful long lines they look like, that's the iris. So the colored part of your eye is the iris. If you have blue eyes, you have a blue iris. If you have brown eyes, you have a brown iris. On the left, what you're looking at is the retina. The retina is the back of the eye. So if you look at your eye or somebody else's eye, you can't say, oh, I see the retina right there. The retina is towards the back of the eyeball. We can't see it. There was this, how do I say it? What they were trying to do was scientists were trying to develop retina scanning technology. The way that works is that you scan the retina, and in particular, you scan the blood vessels of the retina, and you identify a person that way. Iris recognition is when you scan the iris. Everyone has a different iris. Just like everyone has their unique fingerprints, we all have our unique irises. So iris recognition, you scan the iris and then you say, all right, this is, person A, this is person B. Now they're focusing more on iris recognition than retina recognition, simply because our retina can possibly change as we age, especially if we are inflicted with diseases like glaucoma or diabetes. If that happens, the blood vessel pattern in your retina can change, but the iris does not change throughout your lifespan. So, and on the left-hand side, what you're looking at all the way to the left, the blue one, that is an iris scan. So the scanner is focusing on the iris and basically mapping all the different features of the iris. And I have more on this on the next slide. So iris recognition is highly accurate, even more so than fingerprints. Our iris will form and remain constant at birth, unlike a retina, which can change if we become diabetic or have glaucoma. The iris scan will map the features. So features would be color pattern, curvature, lines of the iris. And like I said, each human iris is unique. So, it's pretty accurate. It's not going to confuse me with, let's say, my sister. Iris recognition can be or sorry, I missed the third one. Iris scanners detect movement as well, so you can't use a picture to fool them. And I wish I had inserted a picture of what an iris scanner looks like, but when you go to a store and you use a credit card machine, the one where you swipe, you know, that rectangular credit card machine, you swipe your card there, that's what a iris scanner looks like. So obviously you have to be scanned first, and just like you have to be fingerprinted to be in the database, your iris has to be scanned, you have to be in the database, and then you stand in front of the iris scanner, just like that credit card machine, and it'll immediately scan you. And it's not that you have to stand very close to it or you have to be very, very still. You can just almost pass by it, pausing for like a second, and it'll scan you. And you cannot use a picture to fool it. I researched that because I was wondering if it's, you know, if it truly is foolproof. It works even if you wear glasses or if you wear contact lenses. This technology can be installed as software into an existing computer and digital camera infrastructure. So it can be easily used. That's my point here. So since we're trying to move towards, you know, faster, easier authentication and identification, iris technology, iris scanning, or iris recognition technology is something, they're still developing it. And it's not that widely used yet. It's still in the works. So, but you know, if offices, high security offices, airports, and factories wanted to use it, they can. It's very easily installed. Uses airport. So obviously, you know how we have long airport lines. If we started using iris recognition technology in airports, that would happen much faster. So you could scan, I think the statistic was 20 minutes, or sorry, 20 people in 1 minute. So that's not too bad for airports during the busy flight season. High security offices, factories, so instead of having a badge or something like that, you just basically, you know, walk by the scanner and you're good to go. And then Minecraft. So for anyone who plays Minecraft, perhaps you already knew this. I didn't. I don't play it. But there are YouTube videos where they will teach you how to make a door that opens with iris scanning. So even Minecraft now uses it. Bonnie, should I answer your question right now? So Bonnie's saying, how would this work with changing light, causing your pupil to widen? Would that cause issues with iris recognition? That's a very good question. I don't think it would affect it, because so our eyes will widen, or the pupil will constrict or dilate in response to light. If you walk into a room that is brightly lit, your pupil will constrict. If you walk into a room that is really dark, it will dilate to allow more light in. I didn't come across anything that directly addressed the widening or the constricting of the pupil. However, iris scanning technology does work in any kind of lighting in the room. So I'm assuming they took that into consideration. I mean, it works with glasses, without glasses, with contact lenses, without contact lenses. So I would think they would have taken that into consideration. So I apologize, Bonnie. That's a very good question. I don't have a direct answer, but I think it would still work with that. Voice verification. So voice verification is something that is a technology that still is not as developed as the ones that I talked about earlier. And truthfully, it doesn't have that many uses. However, post 9/11, they did consider working on voice recognition as well as a means to identify someone. However, you know, even if you think about it, how are you going to use it? The only way you can use it is if you are hearing somebody's phone conversation. And if, I don't know if any of you were born before 9/11 or after, but Patriot Act was passed after 9/11, where they could monitor or could listen to conversations, private conversations, so phone conversations, etc. Perhaps voice recognition or verification would have worked there. So how does it work? When we speak, we emit sound waves. So what you're looking at in the picture on the left, that's exactly what happens. We are emitting sound waves that go into the ear, and then, you know, magic happens in our ears and we listen to the other person speaking. So what they do is they will map our sound waves, and it'll recognize our voice. It is not as reliable as other biometrics like the iris scan and facial recognition. And like I said, it has very limited uses as well. Signature and keyboard dynamics. This was a very interesting one that I came across. It was something new for me as well. And so I've been talking about biometric identification. And like I said, biometrics is a physical feature that we have, right? Our voice, our fingerprints, our iris, retina, our face. This is more behavioral. So it's not true biometrics, it's more behavioral biometrics because it's not based on a physical feature. And it's not widely used either, but it is suggested that this is one of those technologies that we should perhaps research and build on for future use. So what is it? So it's two things. It's basically how you sign your name. So signature dynamics and keyboard dynamics. So every time you sign your name, we all have our own particular direction, velocity, and even pressure with which we sign our names. Isn't that interesting? And so, and same with typing on our keyboard. When we type on keyboard, the speed, rhythm, pressure with which we type is somewhat unique to everyone. And so we would use this information, direction, velocity, pressure, speed, rhythm of our signing our name and typing on a keyboard as a means to identify. And then ideally that would be used to identify you as a form of biometric identification. However, like I said, it's just, it's one of those things that is suggested, but it's not really widely used. Natalie, I hear you. And that is it. That is all we have. If you guys have any questions, you can go ahead and type them. I do not remember biosig.
I wondered if any students, we did, it's maybe Misty remembers, but maybe 2017 was when we switched, but students had, you would use the mouse and it was like a number code. You would use the same number code and you would do it with the mouse. And that's how you basically said, this is me, Natalie Russell taking this exam. So it's similar to
horrible.
It was horrible. I would say it wasn't awesome, but it was based on the way that you moved the mouse, right? For those letters or numbers or whatever it was.
It also had issues with people for ADA reasons.
Yes, that's true. Absolutely. Yes.
I did see a student question earlier, and I'm thinking it might be more of an appropriate question for either our political scientists or our historians that are speaking tomorrow. But it says, is it concerning that we're approaching the 20th anniversary and the Taliban has now taken control of Afghanistan? I don't know if either of our biologists would like to comment, but if you would, the floor is yours.
I think you're right. I would leave that to the political scientist, social scientist, maybe military advisors. I just don't feel like that's my area of expertise. What about you, Amna?
Same here. I mean, my in-laws are Afghan. They were actually refugees who came to the US in the early 80s. My husband was born in Atlanta, Georgia. So they don't have any family left in Afghanistan anymore. They do have, I think my father-in-law has one or two friends there. And I mean, I cannot comment on that question, but all I can say is everybody is concerned. Afghans are concerned as well. It's an unfortunate situation. Hopefully some good will come out of it, but yeah, I'll leave it to the political science instructors.
We do have two historians speaking tomorrow, so if anybody's interested in that, highly recommend you come to that one because they are going to be talking about the legacy of 9/11, and definitely what's happening now falls into that. So if we don't have any more questions.
It looks like there's one question about handwriting and
oh, I'm sorry.
No, it just came in the chat, and that's a really interesting question. And you're right. I think handwriting comparisons can be really tricky. There have been a lot of cases in history where people have been able to forge different handwriting. So I think the scans like what Amna mentioned, where it's actually a physical characteristic like your iris or something that you can't really fake, right, or change, are going to be much more authentic than something like handwriting.
So I just put in the chat the link to get credit. If you've come to another one of these, I see a few repeat names. So if you've come before, please make sure you use this form because they are each specific to the talk you're attending. The forms are very open-ended, so you're able to fill them out with what you liked, what you enjoyed about this presentation. And if you have any ideas for future presentations at the Connect campus, please let us know. We absolutely read every single one of these forms. On Tuesday of next week, I will go through all of the forms, and then I will be sending out to your instructors a list of who attended what. So this is how you get credit. Some instructors might also have you do like a little small paper or a mini essay, but this is the starting point. Kamisha, if you're one of my students, go ahead and email me because I do it a different way. If you attend live, you automatically get the credit. If you watch the recording later, then you have to do an assignment. So Natalie, Amna, thank you so much for doing this. We really appreciate it. I know it's nighttime and I know you have families and you'd probably like to be spending time with them right now, but we're just really appreciative that you gave your expertise and we're able to do this talk for our students.
Thank you for having us.
Yeah, thanks, Misty. Appreciate this whole collection of talks you put together. Y'all have a great evening.
Thank you.